I think we're getting to the point where we can maybe go ahead and get started. It's wonderful to have everyone here, and I can see people are still working on joining. Um, Andrew, looks like, yeah, great. It looks like we've got everyone. I am excited to get the Data Center Solutions uh, webinar started. Before we begin, I do want to do sort of the normal logistics. I think everyone is getting used to online webinars, so there's probably nothing new, but we really use our Q&A function here. So throughout, if you have any questions, please submit them in the Q&A section. You can upvote other people's and you can comment on those questions as well. So it's a way to kind of keep the conversation organized, and the questions that get the most upvotes pop to the top for me. Makes it a lot easier for me to prioritize what you all want to hear. We will send out a recording of the webinar. We will send out a PDF of the presentation today. In the follow-up email, we will also include 2 of our case studies on data centers. And with that, I think, we're going to get started. I'm going to start by introducing the speakers. So I am Kim Johnson. I'm the Director of Marketing. I'm just going to be hosting today. We also have Matt Conger, who's the Director of Business Development for Southeast US. He also does a lot of ecosystem things and has really taken that on. He also covers Latin America, so huge geography from Matt. We also have with us today Andrew, who's our Director of Hardware Engineering, and we are excited to have you here. He just celebrated his 6-year anniversary with Igor, so one of our longest employees here. He kind of knows everything, so feel free to give him the challenging questions. And then we've got Jamie, who is our first outside of Igor guest on our webinar series. We welcome you. He's from the Baker Group, project manager, has more than 30 years of hands-on experience in the electrical field. He has a background in design and implementation of electrical, light safety, parking, security projects, and does all of the rest, planning, budgeting, managing in a technical environment. So we're really excited to have you join us, Jamie. And before we really get started, since you're from outside of Igor, can you just give us a quick overview of what the Baker Group does?
Absolutely. Well, thank you, Kim and Matt and Andrew, for allowing me to be part of this webinar. It's a pleasure. Baker Group is a full-service contractor located in Des Moines, Iowa, and we've grown to 650 plus employees since we were founded back in 1963. We have electrical, mechanical, sheet metal, building automation, technology, and service that, we perform work across most vertical markets in the commercial and industrial space. We specialize a lot in design build projects and have over 20 design professionals on staff. But in recent years, we've really been focused on, growing our mission critical work at the various data centers here in Central Iowa.
Wonderful. Well, thank you. Since data centers is the topic today, we're going to just give a quick background on data centers. And I think, when we were researching putting this in, how do you quantify this growth in something that when it's really astounding? So 29 billion is the number of connected devices that the TIA group is predicting will be connected by 2022. That's just 2 years from now, less than 2 years. And this is really directly derived from the growth of the IoT world. And all of these IoT devices they produce so much data. That's the benefit of them, right? They're connected, they produce data, you can do analytics, but you need to store that somewhere. So to a lot of consumers out there, the cloud is this mysterious thing that they maybe pay 99 cents a month for to put their photos on. But the reality is data centers are where these cloud operations are housed, and they are very physical things. It's very, very much a real thing that is incredibly complex, despite being really built for one purpose. So I think that's really exciting, and it's interesting to think that even within the data center field that there's so many different types. There's certainly the self-owned or enterprise, and these are typically data centers that are built and owned by companies, usually on their corporate campus. And these can technically be small. They don't have to be massive things. But what we're seeing more of are the co-location, where a company might rent space from within a data center owned by others and located off company premises. And that colo data center is a company that just specializes in running data centers. They do the building, cooling, bandwidth, security, hosting. They manage the servers and storage. Other companies just pay them to do that for them. And then what I think is what's really driving the growth in data centers now is what's referred to as hyperscale in the market. And that's the cloud data centers. And those are the ones that you and I might, the layperson might recognize more. They're off premise, they're data centers that host the data and applications in the cloud services. And usually this will refer to things like Amazon Web Services, Microsoft Azure, IBM Cloud, those sorts of organizations that extend externally and really are growing tremendously. So, I think this is where I kind of, let's talk a little bit about this before we get too deep in. Jamie, what type of data centers, what does the Baker Group tend to see here in Central Iowa?
Well, we see all three types, but we spend most of our time in the hyperscale and the enterprise, I would say.
Yeah, and so I'm just going to toss this out there. Cisco, all these organizations, they're saying data centers are growing, and they're talking about in total storage they can host and also square footage. So I just want to get a sense, maybe Jamie, but also Matt, what are you seeing in terms of the market? Are you seeing new builds? Do you want to just comment a little bit on what the trends are in this market growth?
Well, here in Central Iowa, it's definitely new builds. We haven't had a lot of data centers prior, to the last 10, 15 years. And we think that's going to continue to keep growing with as much, online activity as there is, as far as commerce, and as well as, the more people working from home. So your remote workforce is, becoming greater every day. So it's really important to maintain those data centers.
Yeah, I'm seeing, or as a company, we're seeing immense growth across globally, right? And even here in the States. So more data centers are, we hear about talking about edge intelligence and getting data centers closer to the edge where the activity is. So colos being located in major markets, even in like downtown markets, not in large footprint areas. So you're seeing all kinds of sizes, whether it be just campuses associated just for that one function to something being incorporated into like an old library or even like a new build commercial high rise.
Yeah. And so, today we're gonna start getting into actual solutions for data centers. So in order to get to that point, I skipped ahead a little bit there. Let's set the stage. I think a lot of people on the audience are relatively familiar with data centers, but just to make sure we're all on the same page, Jamie, do you want to give us an idea of what it's physically like to be inside more of a hyperscale data center, the ones that you see in Central Iowa?
Well, it's very, very secured, very what's a good term? Not institutional, but it is. There's not a lot of wow factor going on there. It is very large electric rooms, rows and rows of racks of servers. It can be loud at times. There's not, there obviously no windows to speak of. So it's not a real glamorous place to be inside, but they're definitely well thought out most generally, just for the efficiency of everything.
Function over form.
Sure.
Yeah.
Jamie, is it pretty hot in there? Like, I think of data centers, we talk about, we want to keep things cool, but in general, what's it like for you guys working in those spaces?
It's very cool, and the where the racks are for sure. The electric rooms get a little warmer just with all the equipment in there.
Are there a lot of people? You know, when we talk about you being in there, you're usually in there for specific projects. Do you find that it's actually a pretty busy place?
Not really. I mean, it's, unless there's some other contractors or other projects going on in there, that for as large a scale of these facilities, it's a relatively small, workforce that actually work on the data center or in the data center, I should say.
So, and another point that I thought was really interesting, and maybe Andrew, could you take this one? You've had a lot of experience working in the projects we've had in data centers. What's it actually like to get in and out of a data center?
Sure. You have to be very patient because there's multiple layers of security, both at the front gate as well as the main security entry point, and so it's very process oriented, and multiple layers of security and such that you need to pass through. Make sure you're properly checked in with the security office and what other departments you're working with within that data center. So you really don't be in any rush. Just take your time, go through the process they want you to, and get on with your day and your work.
So I think, in each of these answers, there's sort of this framing, especially we're probably going to focus on hyperscales a little bit today since we're really seeing growth there. But they're not designed in the same way. They're very different from a lot of our other smart building projects. The needs and the pain points that these data centers face might look familiar. Of course, in an office, we want everyone to be safe and secure, and you don't want to spend too much on your electrical bill, but in a data center, these do take on slightly different meanings. With safety, just the massive size of the hyperscale data centers, things like getting people out safely in terms of inclement weather, also physical safety because of the electrical rooms that they're working in and the stuff they're working on. Not being careful could have very serious consequences in a way that other spaces don't necessarily face. Security, the getting in and out. When you describe patients, I mean, I think of patient person, and it takes them 40 minutes to get in and out of some of these, sometimes one way. So it's because any project, hardware update or renovation involves bringing outside people in. And, finding that trusted partner is so important in that because there's tricks and things we've learned as we've worked with these data centers, how to be better partners to help them with their security and sense of trust. And then cost, I think this is, I might want to spend a little time here and pick your guys' brains on what we're really trying to identify here as challenges. So, Jamie, do you want to talk a little bit more about the safety concerns and how they deal with that within the data center itself?
Sure. So most data centers, they're very safety conscious. And when I mean very safety conscious, I mean they're very safety conscious. It's very important for them to just mitigate any kind of risk that could, slow down or stop any of their operation. And especially when there's, contractors like us working in the facility. If there's a safety incident, here in Iowa, or if it's another one of their remote locations, sometimes those safety incidents can, cause a regional or national or worldwide stand down. Because if they know it can happen at one location, it could possibly happen at another location. So they just want to stop everything, regroup, talk about it and figure out what happened, if it can be replicated again somewhere else. And if they can, then how are they going to mitigate that risk? So it's challenging at times to work in those, but they are very safety conscious.
Okay. So, Andrew, does this safety, when we think data centers, actually, I immediately thought cybersecurity, but when we're talking about the physical structure of the data center, what does security mean in terms of challenges that they have to overcome?
Yeah, sure. There's you know, many layers of it, of course, that have been engineered and designed into it. Whether it's physical security of the building, and or cybersecurity and such, and how our solution can fit in with that, and adhere to the customer's standards, customer's requirements, and such. Whether that's isolated, completely isolated network, or integrated into their management network.
So then, all of this right off the bat, when we talk about a physical safety incident causing a shutdown, or that sort of security elements, these all already are sounding like they add cost to operating a data center. But Matt, do you want to comment a little bit more on some of the cost challenges that these data centers face?
Yeah, I mean, when I think about cost, I think about one is cost associated with building these facilities, designing these facilities, and what goes into them in order to keep them safe and secure, right? And so today, there's immense amount of precautions that are taken that really drive up costs, both in materials as well as the length of time to construct these facilities, design and construct them. And then once we're living and working in these environments, and they're continuously changing, is like, how can I operate them more efficiently? How can I keep my team off, back in the office and not out on the floor? And so maybe there's a way to implement like technology or IoT in order to better manage these buildings and to create to help with safety and security.
Excellent. Yeah, and I think we'll touch on some ideas and ways our technology and working with trusted partners like the Baker Group and Igor can help bring those costs and risk down.
Yeah.
So let's get into it a little bit more. I want to turn it over to you, Matt, and let you comment a little bit more about the technology.
Yeah, sure. So we described a little bit of kind of the challenges, right, where we're talking about safety, security, and cost. And so before we jump into kind of what's the solution is, I like to quickly talk about who Igor is as a company. So, at Igor, we like to say that we enable intelligent buildings. And so those intelligent buildings or intelligent cloud operation centers, they foster things like productivity for people, fulfillment or happiness, safety and security, all while maximizing energy savings and minimizing maintenance. And so those are all like real good, feel good terms, right? But how do we actually do that? So the way this is accomplished, and we put together a quick little diagram here to kind of speak to it, is that so, by deploying our Nexos IoT platform, we put edge intelligent devices throughout a physical infrastructure that allows us to power and communicate with all kinds of these disparate objects, which might be like an environmental sensor, or a light, or a momentary contact, or even like a Bluetooth assets and more. And then these edge intelligent devices, or we call them nodes, work in conjunction with the on-premise software, which is our Nexos software platform, to unify and automate all these events. And so we then offer, on top of that, optional cloud services that can then allow you to globally manage or offer global intelligence to access and contain greater levels of analysis for your properties. So on the next slide, where the Nexos platform is now available for use in these data center environments. And so what does that kind of deliver at a high level? So it's going to deliver real-time location services, lighting or illumination, safe illumination, as well as environmental monitoring, all at the lowest total installed cost, right? And so this is deployed on top of a low voltage power over Ethernet infrastructure. And the reason we leverage power over Ethernet for these applications is because, one, it's a very secure backbone. It's super reliable. The speed for backhaul of information is a must in order to deliver near real-time solutions, as well as increased security because of power over Ethernet. As far as like delivered outcomes, right? So we talked about cost, we mentioned safety and security. So what are we delivering? So what we're going to deliver is the ability to locate and account for staff, visitors, and contractors during both normal conditions as well as uncommon and stressful safety and security events. We're going to reduce lost equipment such as keys, access cards, human lifts, electric vehicles, and more. We're going to encourage social distancing by providing digital contact tracing. And then we're also going to implement and increase the energy savings of 22% as compared to non-network systems. And then lastly, deliver the lowest total installed cost for greenfield projects. And when I say cost, it's really important when you're building these buildings, right? How can I do this effectively? And then how can I have something that's going to operate well over the life of the building? And the way that we're able to achieve those lower costs is like we're limiting things like rigid conduit that it is utilized everywhere throughout through a cloud operations environment, and that's not needed once you go to a digital low voltage infrastructure. Things like lighting sub panels, 12 gauge copper, smaller feeder sizes, faster install, all those things can easily be achieved with our solution that we're talking about here today.
So before we get into the details of the solution, because Andrew's going to be up next and he can bring in a lot of these details, we did have a really good question I do want to interject here from the audience, open to the three of you. But could you talk a little bit about the security of Pue versus wireless lighting controls? And this question is sort of applicable outside of data centers, but we'll take it in the data center context. Anyone want to take a lead on that? Why is Pue, for example, lights connected to and controlled by Pue more secure than wireless lighting?
Well, some of it is inherent to the technology. You know, hardwired technology, obviously somebody would have to get physical access to one of the devices, to the data rack, in order to infiltrate that, or at least there's less surface area for an infiltration, versus wireless, which can greatly expand the attack surface area for somebody trying to do harm to that building.
Yeah, and so I don't like to me the solution we're delivering is leveraging power over Ethernet. Like we do have the reason we leverage power over Ethernet because it can deliver a lower total installed cost and it's more reliable and it's more robust and it moves the information around that's required to deliver near real time. And you can't get that with a wireless infrastructure. And so when you leverage low voltage infrastructure, it's not really a question of should I do this or should I do something else, do that or this. It's that the benefits of PoE and the cost and the reliability are so much greater that it's much better to utilize a PoE backhaul.
And I would add on that the wireless, with wireless solutions, you really have to take into account the environment you're in, and data centers being predominantly steel and concrete doesn't really lend itself very well to wireless.
Thank you. All right, I think we're gonna start pressing ahead again. I'm gonna turn it over to Andrew. And give me just a moment to actually pass the control to him so that he can make sure we're going at the pace he needs.
I knew I would double click and accidentally go ahead a slide. Okay, there we go. Thank you, Kim. So I'm going to spend a few minutes really talking about the hardware and the nuts and bolts that make up the Igor data center solution. And this is a solution that we've honed and optimized through multiple data center solutions and such. The core of this solution is really based upon prefabricated, pre-wired, pre-programmed and configured racks. From an installation standpoint, it's really designed to just be rolled into place, make your field terminations, your power connections, and be able to hit the ground running from that standpoint. We have designed this as with two standard versions, better and best, which we're calling them, and so I'll go into details on each of those levels next. But even with those standardized versions, we do have plenty of customization available, because obviously every data center project, even if it's the same company, same owner, from one data center to the next, they're also trying to make improvements, make optimizations. So our solution is designed to be customized and be flexible to work within those changes from one data center to the next. So going to try and advance the slide here. Here we go. That's better. Okay, so what we are looking at here is the front and side views of our, we're calling our better solution for the data racks. And so in this case, at the top of the rack, we have a number of node shelves. And see, these are sliding shelves. They contain the Igor Poe nodes, which you can think of as, really the LED drivers, but they've got a lot more functionality than that. These nodes can also pick up sensors and switches and et cetera, and have a lot of capability beyond your typical lighting driver. And so we can encompass those in these vertically mounted shelves, which can slide out for maintenance purposes, but also allow good airflow and such to keep everything running nice and cool. And then below those in the rack, we have some typical cable management along with the actual PoE network switches. And so these are going to be IEEE 802.3 BT switches rated for the 90 plus watts per port. And then below that in the rack would have PDUs as well as potentially what is labeled there as the Igor Gateway Server. That's really our on-premise network platform. There'd really only need to be one of those per data center, but I showed it in this diagram for demonstration or illustration purposes. So over on the right side, you can see where we've got a couple of LED fixtures indicated, and with some 18.2 cable running from some terminal blocks on the back of the rack out to those fixtures. And one of the advantages of PoE and the Igor solution is that those cables don't need to be ran in conduit. This is all low voltage based power for the lighting. So these can be run right in the cable trays, which every data center has a ton of cable trays going all over the place. So these can be flown in those same cable trays, right along with the data, the network cabling, because this is all DC-based power. So there's no, AC, noise, interference, etc. Going through that. So it's not going to affect the data throughput of any of the other network cabling in those trays. And then also for any wall switches, motion sensors, etc., any other types of sensors, those would also have cables run through those cable trays back to the rack, landed on pre-labeled terminal blocks and such. So it's easy to trace, from one end to the other for troubleshooting purposes and such, where everything's going. Nice, easy, compact type solution here to try and optimize that installation process, because as we've already discussed, it can be very time consuming. Just extra time needs to be allotted for data center projects, getting manpower into and out of the building, and et cetera. So anything else that can be optimized saves time and saves money. So looking at a few other features of this level of our solution, lowest total installed cost, pre-built racks, as I mentioned. These, based upon typical 36-watt fixtures, each of these racks can support up to 160 fixtures per rack. So if you're looking at, say, 75 square feet up to 100 square feet per fixture, you're looking at 12,000 to 16,000 square feet. Sorry, I tried to do the math beforehand. Hopefully I got that right. So a decent coverage area of lighting per rack. And these racks can be installed in electrical rooms, data closets, really wherever the designated space is, and obviously within proximity of the fixtures and sensors they would be serving. These would incorporate all of your standard lighting control functionality, occupancy, vacancy control, local lighting control via wall switches, scheduling, etc. There's not much daylight harvesting that goes on in data centers because of the lack of windows, so that's really probably not something that would be covered. but they are adaptable based upon the power supply voltage available, whether that's 240 or 277 volt AC. And these are also great for a retrofit application, such as a Redwood Gen 2 type application, where a lot of that existing infrastructure can be saved and reused in order to make the cost as minimal as possible.
Hey, Andrew, so like back on that last slide, are you telling me that the only place you need line voltage is one place, and then everything from the rack downstream is all low voltage?
Absolutely. Yep. You're bringing your line voltage really into those PDUs. PDUs are feeding that voltage out to the PoE switches, and then everything after that is either 55 volts DC or less. So so very safe, very easy to work with from that point onward. And so if you've got somebody out on a lift, out on a ladder, working on fixtures, etc., it's all low voltage out there. It's all class 2. Very safe and easy to work with. So moving on to the best solution, the top level solution we have as part of this. Again, we're seeing the front and the side views of the data rack. One thing you'll notice is this solution does not have the node shelves that we saw on the previous solution. In this case, those nodes are actually mounted out at the fixture. Ideally, if there's been coordination with that fixture manufacturer, those nodes have been mounted at the factory, pre-tested at the factory, and arrive at the job site ready to go. With just RJ45 ports to plug in cabling. Those fixtures would also incorporate advanced sensors, which would include motion, temperature, and daylight detection, along with Bluetooth real-time location services capabilities. So looking at those devices on the right side, the yellow cabling would essentially be your Cat6 home run cables from the patch panels at the racks, going through that cable tray out to the fixtures. And then the blue cabling is showing how we're leveraging our Igor bus daisy chain technology. So the blue cables could be prefabricated Ethernet, patch or interconnect cables, depending on what terminology you like to use. But simple RJ45 connections at each fixture, and also down to that wall switch down at the bottom, an Igor-enabled wall switch with a simple RJ45 connection. So all of that makes this very quick and easy to install. Once you've got the fixtures hung, then it's really just getting the cables connected to those RJ45 ports, and away you go. As such, since we don't have the node shelves in this solution, we can support more lights. We can go up to 288 lights, as well as up to 144 wall switches and such, which would really be way more than you'd probably need, but just showing what our total capacity capabilities are. So again, these are pre-built racks similar to the better solution, designed to really be rolled into place, connect your power, and then as far as field terminations, this solution would have the patch panels and simple, typical Cat6 punch down on the back of those panels, and then those cables will go out to the fixtures or out each pair of fixtures. And as I mentioned, support up to 288 fixtures per rack. All the standard lighting controls I mentioned before. Again, similar compatibility on power supply voltage 240 or 277. But as I mentioned before, once it comes out of that RJ45 port on that PoE network switch, then it's class 2 low voltage, much safer and easier to work with at that point. But this solution also has some of the additional functionality of the real-time location services and additional asset tracking potential capabilities incorporated into it. So got one more slide where I'm going to take a little closer look at those voltage options. Typical commercial building, traditional data center in the past has incorporated, your typical 277, 480 volts, 3-phase power distribution in the building, and so while that's great for some of the higher power applications, it can have the requirement for more step down transformers in order to power all of the IT equipment within the building. And so anytime you have any transformers or other equipment, you're having efficiency loss through that voltage drop through that transformer. So some newer power center or newer data center power designs incorporate a 415 volt, 240 volt AC solution, which is much more friendly and compatible with your typical IT equipment range, which typically runs from 100 to 240 volts. So it matches perfectly from a PoE aspect as well. The higher the input voltage to those PoE switches, the more efficient the power pass through, the power transfer through those switches. So, from our standpoint, any new data center that's incorporating the newer power distribution design is getting to be as efficient as possible. So with that, I will turn it back over to Kim and Matt.
Yeah, I'm going to just interject with a couple of questions I think are a little more relevant to your section here before we move on. Carl's just wanting to clarify that he is assuming these are not high bay fixtures. Is he wrong? And what's the max ceiling height here?
Yeah, typically, I'll take this one, Andrew, if you don't mind. So typically in the environments we were working in, we're usually using 4-foot suspended linears, right? So they're hung from hanger chain or aircraft cable, and they're usually at, I'd say 12 to 15 foot mounting heights. Can we do high bays? Absolutely. Because we're 802.3 BT standard, we can accommodate easily up to 80 watts per port. And so we can push a lot of lumens with different fixture manufacturers to accommodate that as well.
And then a little bit about maximum length of PoE. So James and David both inquired a little bit about this. What's the maximum run length for 18 AWG from a rack node shelf to the furthest fixture?
Sure. So a lot of that depends on how much current you're trying to push through that cable and such. Obviously the higher the current, probably the higher gauge wire, thicker copper you want to use for that. We actually, in our node data sheets, we've got some nice tables in the back that show some recommended cable lengths based upon wire gauge and how much current's getting pushed through. So for 18.2, if you're pushing 1,000 milliamps, you're probably, to achieve a 1 volt drop or less, you're probably in that 75 to 100 foot cable length. So if you need to go farther, which obviously there's going to be scenarios where you are, then you may want to bump up to a 16.2, 14.2, etc. To ideally try and keep that voltage drop to 1 volt or less, between that rack and the fixture it's serving.
Okay. Well, thank you. We can certainly take more Q&A at the end. And I think we'll move on to discussing a little bit more detail about what the value is of some of these solution options. First one we're going to talk about is real-time location services. So Matt, did you want to talk about this a little bit?
Yeah, I'd love to. Thanks, Kim. So, we touched on at the beginning is that what are some other things we can do with these systems? So with our best package, we're able to basically allow you to dynamically track mobile assets like what I mentioned: people, keys, lifts, electric vehicles, and more. Off to the left here, we're showing like a loop videos showing a very floor plan map of what something could look like. So with this, we're able to monitor wearables like wearable panic buttons that for during a safety event or some other alert. So you can see one of the objects here that's moving around, it turns red at some point to indicate that one is occurring some sort of panic button press. And then what's really wonderful about the solution is because every light basically has Bluetooth enabled in it to see these local objects, we get a really, really, really granular coverage of this package, right? And so we're able to deliver accuracies to 2 meters on a continuous and real-time basis. The system can easily be set up to provide historical heat maps as well. And so you can imagine what you might do with real-time location services. And so with that, I kind of want to ask the team here is what else might you want to do with some real-time location services?
I'll jump in briefly. You know, I am in marketing, but we're all very aware of current events, and it was mentioned briefly on the previous slide. But you know, I'm seeing this, and I'm seeing contact tracing. You know, it's really screaming that social distance, contact tracing, implementation, and just being able to understand where people are, who's interacting with who. So, in the case of an individual testing positive for COVID-19, historical data like this could help determine which people were closer to that individual than recommended, maybe for, you know, some sort of minimum length of time to really understand risk. And I think that's valid in a data center, even if it's a huge space that allows for social distancing in theory. The reality is, it sounds like for projects, people are often working very close together.
Yeah, I mean, there's definite choke points, right, Jamie, where you're gonna have overlap, and so if we can look back and see where those are, they can better operate, right? Because we talked about how events can shut down operations, and that's an absolute no-no in these 24/7 facilities. So anything we can do to prevent these kind of challenges are key.
Absolutely. And also, you know, from my perspective, if you could track some, you know, pieces of high value equipment, you know, if let's say one of our guys leaves a tester or something in a electric room or what have you. I mean, if you could go back and find it easier rather than just walking all over the data center, you know, searching for it, it would be good to know. Or if somebody did decide to move it, and you could find out why, and I think that'd be pretty valuable.
Awesome.
Yeah, and from my experience, you know, as you're moving around the data center trying to get some work done, usually, you know, the vast majority of the doors are locked. So you either need a hard key to access those rooms, or your DCAT for a key card type access. And if you happen to set down your keys accidentally and walk out of that room and such, it might be good to know where your keys are. Not that that's ever happened to me, but I'm just saying if that were to happen. So.
Yeah, and I'm sure there's more ways you could use this that we're not even thinking of, you know, and it really that value in a huge place where racks might all look the same, you know, where were you last? I think that certainly is very, very valuable. And Matt, I'd love to hear a little bit more taking that on like what we can really do to make it valuable.
Yeah, sure. So like with the Igor solution, it does include an option for a graphical floor plan application that's going to show you those locations of mobile assets and more. And then this means you can look to Igor for the hardware infrastructure and the end user graphical user interfaces for viewing those RTLS assets. However, like in a lot of cases with the clients we work with, they already have their own, whether it be a homegrown dashboard type application or maybe one that's been developed by a third party like Schneider or IntroSim. In those cases, like the RTLS information may easily be integrated with those, okay? And so the idea is that you put in the physical infrastructure, all the Bluetooth assets goes along with that, and then the way in which we share the data or information for them to embed into their own dashboards is we've got an open Restful Api. And so that API or application programming interface will share the X and Y coordinates of an object or of a button press or something, as well as like what space that object or tag was in. And so we point this out because our solution, it's flexible for whether it be like an independent turnkey type deployment or integrations with others. Those are the things that you have to keep in mind. Go to the next one, please.
This is always my favorite part. You know, we've talked about what is possible today, and then taking it to the next level. You know, if everything came together, what's truly possible in a data center, not just the practical nuts and bolts that we're really good at and we can do like the back burner, you know, you can do in your sleep almost, but well, what can we do to really stretch ourselves to think beyond, you know, just, you know, fill in the blank, just lighting, just real-time location services. And we've kind of started to touch on that, but love to maybe turn it over to Matt and the team here to talk about it.
Sure. So, one of the things is like could lighting be used as visible beacons, or maybe some sort of path of egress? Because like Jamie, aren't those? It's pretty loud in there, right? And you're wearing air protection. Is there things that we can do with light to help indicate ways to get around?
Absolutely. And I think you could also maybe use it for, a beacon for different events, whether it be a weather event or fire or some life safety event.
Yeah, absolutely.
I think that'd be pretty helpful. When you were talking about the asset tracking, and we were talking about, your real-time movement. If, let's say, I did have a piece of equipment out there that was tagged and we were looking for it, could you maybe have that light that's kind of in the light that's reporting that piece of equipment? Could you just have that one light maybe do a little beacon?
Yeah, like there's a couple things you can do. Like one, because we're controlling every disparate light object in the building, and so we could flash the light above an object to indicate that that's where it is, right?
Yeah.
Or if it was color changing, we can indicate that so with color. I think about that same thing for intrusion detection, right? So could we, let's say somebody opened one of the data center, one of the cabinet doors, like on a rack or something, and so
Sure.
we could definitely call out that, hey, there's activity going on, one with the RTLS data, but then two with the physical lights in the space to indicate that's where something's happening.
You can track
Something else
by the camera.
that could be incorporated, as we mentioned, data centers, once you're back in the bowels, they don't have any windows, and so working in that type of environment for a long period of time, can wear on you a bit. So being able to incorporate some tunable white fixtures, some human-centric lighting, and incorporate, circadian rhythm into that control can, help, whether those contractors or data center employees that are spending long periods of time without seeing any natural daylight, help keep them sharp and alert and aware, because of course we talked about security and for the security personnel that are working, back in these areas, it's important to keep them alert and awake to properly do their job as well.
Good point.
And then you've got, minimum lighting for the security cameras. You can certainly, this isn't necessarily like things we're talking about are actually quite possible. You just have to think about them and implement them. But there's cameras everywhere, and I'm sure there's minimum thresholds for lighting that are required in different areas that this could be customized to. And I think that's very interesting. And that personalization, Andrew, you could have circadian rhythm with your lighting, but, are there areas of the data center that would allow for, that combination of real-time location services where someone walks in and it can actually kind of customize the environment to best suit them? Data centers aren't built to be beautiful, clearly, but they can still be built to treat the people inside well and make sure it's a healthy environment. So
hey Andrew, how about didn't you work on a project where let's talk about those cameras some more. So didn't we do a recent project where we had to dial in the light levels to make sure those cameras were functional?
Yeah, certainly. One of the the customer's big concerns, especially during the lighting retrofit, was maintaining minimum lumen levels for the security cameras. So that even as the retrofit was going on, the security personnel monitoring those cameras, could still effectively see all the zones being monitored, and so that was something that we were able to achieve through the process, as well as incorporate low-end trim or minimum light levels into our system to ensure that even when those spaces are unoccupied and the lights are dimmed down, that we're still maintaining the required dimming levels while still optimizing the energy reduction, energy efficiency of that lighting.
Yeah, and then I think if I remember, like, you were able to do that really like with just a global policy, right? Where you said this is the min and that's the setting, and then you were able to implement that across thousands of fixtures, correct?
Yeah, yeah, absolutely, absolutely. I think it was like a 10 or 15% dimming level that was globally applied. And the Igor solution makes that very easy to tweak and adjust, and that worked across a couple 100,000 square feet of data center.
Awesome.
Well, that's really, this is the end of our presentation, but we do have some questions. So I'm going to start to bring them in from the audience. And I do want to encourage the audience to add your questions now or forever hold your peace. But let's start with one by Craig, since we were just talking about Bluetooth and the lighting fixtures. Craig's wondering, can the Bluetooth tracking be implemented standalone in an environment that already has lighting and then migrate the lights over essentially one by one as they fail?
Yeah, I mean, because it's a leverages low voltage digital infrastructure or power over Ethernet, we can easily deploy Igor nodes attached to real-time location beacons, right? And then those nodes could be used, one for mobile asset tracking in these environments, or also we didn't really touch on it, but or touch on it very often, was the ability to do indoor air quality. So that same node that's doing the real-time location services is also there to say, hey, what's the humidity, what's the temperature in this area, right? And so you can imagine the power of those types of objects. You could even monitor sound level if you wanted to, and it just shows the beauty of low voltage infrastructure and how easy it is to deploy, is both as a retrofit or as part of new construction.
All right, so in terms of the questions are at range here, but in terms of network security, this is from Michael. Do you recommend keeping IoT devices connected separately from your main data network? Or not, and why? I can repeat the question, but maybe Andrew, do you want to kick this one off?
Sure.
Or is it not a concern?
We've, throughout all the installations that Igor has done, both in commercial buildings and in data centers, we've really seen a mix of this, and there's multiple ways it can be implemented. In some cases, the PoE lighting network has been physically isolated from the customer's network, separate switches, separate structured cabling, etc. Or it's been incorporated into the building network, the management network of the customer, and isolated via VLANs and such, and other network configuration capabilities, whether that's access control lists and other ways that can be done. So typically when we design a system, we want the edge devices, the nodes, and everything else separated in one way, physically or virtually, from the rest of the network. And then there's really just a single connection point, that Igor gateway server, that Nexos platform. And from that point, then it would either go out to the internet or go to the customer's management network, and thus out to the internet and up to the Igor cloud portal from that standpoint.
Great. James is asking, thanks for this. Well, first of all, he says, thanks for the sensor ideas, but what other examples of non-lighting actuator accessories could be powered by Igor nodes for data centers?
Well, there's, Matt, you probably got more ideas than me. I'm going to make a general statement, then let Matt fill in some details. But we're really starting to see lots of customers come to us with all kinds of ideas. Really, it's anything that can be DC powered, that's typically 100 watts or less. But yeah, we're seeing all kinds of things data center specifically, Matt, do you have some ideas?
Yeah, I mean, I'll just talk to the office area, right? Because there's always an office area at all these facilities, and there is daylight there. So maybe they want to deploy some motorized shades in those environments. So those two are very easy to deploy as PoE objects and controllable as part of the Nexos platform.
Great. And just to wrap up with everyone here, what do you think is something we should all keep an eye on in terms of data centers? You know, if you were to predict a few years out, just having some fun here, where do you think we're seeing the market go? Anything new or interesting you think we should keep our eyes open for in terms of the development of the data center market?
I think we'll see them continue to grow aggressively, and but more on the edge, closer to bigger cities, closer to large numbers of people where we got to move data quickly, right? And so we'll see continued growth, whether that be colos or smaller data centers. It's amazing where they're placing these today.
Yeah, and data centers are incredibly expensive, places to operate. This is a 24/7 mission critical type building, and so obviously it consumes a ton of energy. Hence why we're seeing a number of data centers being built here in central Iowa, because we have cheap electricity. I mean, that's one factor that plays into it. So where the Igor solution can build onto that energy efficiency and lower cost, just helps as well.
Yeah, I think I'll echo what Andrew said. I think the energy efficiencies is what will keep evolving in the data centers.
Awesome. So we've got edge data centers, we've got energy efficiency. I mean, throw 5G in there for fun, right? Like there's a lot of developments that can affect the future of data centers. So to have maybe a flexible smart backbone like an IoT platform built on PoE is a great way to make sure that the current structures can be flexible and adjust to future needs, right? So yeah, unless there's any final thoughts, I want to thank everyone here for their time today, both from the panelists and from the audience. We really appreciate the conversation and taking a little bit of a different tone and focusing on one vertical with this webinar. I think was really an interesting way for us to talk about the